Assalamu alaikum. Welcome you all to this training session. Basically, we are going to discuss regarding the thermodynamics, the chapter thermodynamics, which is related to the second year honors uh, under the sections of physical chemistry. As per our syllabus, we have the few selective chapters which are very important to understand the concept of physical chemistry, and the chapter which are very essential to understand to do well at the exam, especially at the second year honors for national university. The chapters related to the physical chemistry, the thermodynamics, electrochemistry, pH buffer, and indicator. But if you want to have the complete preparation regarding these papers, then you have to go through the detailed syllabus of thermodynamics, and then electrochemistry, and then electrochemical cells and cell potential, and then pH buffer and indicators. The chapters related to the topics related to these papers, that is under thermodynamics, and then electrochemistry, and then pH buffer indicators. As per the analysis of the question paper of the last 15 years, it has been found that the questions related to these papers, most of the questions have come or has been settled at the exam from the chapters, the thermodynamics, which is the paper code of 2222801, physical chemistry 2, then electrochemistry, and then pH buffer indicator. But the one very interesting thing is that if you analyze this, the last 15 years question papers of the national university, in that case you will find that the most of the question had been found from thermodynamics for year thermodynamics. That is the very essential chapters of the physical chemistry. The questions at the final exam will definitely be settled from these chapters, and after analysis, it has been found that at least 3 to 4 questions has been settled at the different years from this chapter. So there is no alternative to understand clearly the concept of thermodynamics and the thermodynamics parameters and the consequences. There are very different aspect of the energy and the applications and the equations. But it is very difficult to understand if you do not understand the basics of thermodynamics, because there are so many equations and then mathematical terminologies which are very difficult to understand without the basic concept of thermodynamics. For these reasons, we have already mentioned the few questions which are very important to understand the concept and to study for the final preparations. The questions has been set at your website page as the suggestions. You will go to that sections to find out your suggestion from these chapters. All the questions that have to understand the concept from the basic point of view, and have to study for the final preparations, and the relevant notes, that I mean hand notes, and the PDF notes, e-notes, and video notes, all have been arranged and also been uploaded at your own page. If you go to your website page, then you will clearly understand. Now, today we are going to discuss as the first basic class of thermodynamics, that is the physical chemistry, second year physical chemistry for National University. So we are going to discuss the very basic concept of thermodynamics. As it is our first class, so we are going to start from the very beginning of the thermodynamics. We have very few concepts regarding thermodynamics, and most of the case we do not understand the concept or basic applications of thermodynamics and the use and consequence and the characteristics of thermodynamics. So for these reasons, we are going to start from the very basic points of thermodynamics. Firstly, when we are going to talk about regarding the thermodynamics, then the first comes to the terminology, that is energy. ENERGY. Energy always converted to various forms, but the most common forms of energy is heat. When we cannot, we know the universal law, we cannot make or produce any energy, and we cannot destroy any energy. Energy only be converted to one form to another form. This is the basic principles of also the science, and this is the basic principles also the thermodynamics. So every element or every matter in this world are related to energy. When there is no energy, there is no work. And we know from the basic concept of chemistry, there is no non-living element. All the elements of the universe are living. When you are thinking about the table, about the computers, about the non-living element, which you can understand that this element, these elements these elements are not living substance. But if you consider from the chemical point of view, from the concept of the structurally, from the concept of electronic configurations, from the concept of the electronic movement, from the concept of disposition of electrons, from the concept of stereochemistry concept, then you will understand that there is no inanimate object in the world. I mean, the fundamental basis of chemistry explained that all the element of the universe are completely living element. Though we cannot understand, though you cannot define that all the element or all the substance around us or in our environment are living. How this come? The most important questions, we cannot define all the elements as a living element, but in terms of electronic configuration, or in terms of the concept of chemistry, or in the eye of the chemistry, we can define that all the elements are living. This is the most important point, the living element. I mean, all the element or all the substance is a compact substance of energy. So there is nothing without energy. If there is any substance which is energyless, or which cannot be defined in terms of energy, then the element is useless. So each and every element has energy, and energy can be converted into heat. So we can summarize that there are two things. Number one is energy, and the another one is heat. So energy can be converted into heat, and heat can be converted into energy. But energy can be converted to many forms. But today's discussion is the conversion of energy into heat, because we are not focusing to the other points of the other form of the energy. Now, as we are going to discuss going to understand the concept of thermodynamics, so we are going to discuss the concept of energy into heat conversion. Okay, then as you know, we have already discussed that heat is the common form of energy. So every substance are constituting are composing of energy, I mean heat. When you are considering the heat, then there are now when you are considering regarding the energy, then you will find that there are a few forms of energy. I mean, internal energy, external energy, chemical energy, magnetic energy, so many. But when we are considering the conversion of energy, then the terminology system comes from. Then what is system? The system is defined as the any part of the universe. Then we can draw a picture, that is this is a box which is designed this way. This is a piston. This is a piston, and then this is the density of the piston. You can understand. And then this is the outer side. In this outer side, the cylinder has been kept. So you can understand that this is the boundary, outer boundary, BOUNDERY. This is the boundary. And then this is the piston. And then these are the ideal gas. These are the ideal gas. IDEAL, ideal gas. Okay, then you can understand easily that there is a surroundings, or there is in the outer boundary, and in the outer boundary we have kept a piston with the compositions of ideal gas. Then any part, we have, as we have already discussed, that the system is the any part of the universe. Then if there is outer boundary, then this is inside, in the inner side, completely the inner side portion. In the complete inner side portion, I am drawing this portion is a system. This is also a system, because this is the any, as we have already discussed, the any part of the universe is a system. So this is also a system. This is a classroom. This is also a system. These are the classroom. This is our classroom. So these are also a system. So any part of the universe can be defined as the system. System can be classified into two different sectors: systems and environment. So at a system, so any system composed of two types of parameters, that is systems and then environment. Here is the outer boundary defined as the environment. So the system cannot be defined without environment. So when we are thinking about the system, then there is another part of the system. This is called environment. Now the question is, what is the application of thermodynamics, and why we have to understand the concept of thermodynamics to under the physical chemistry. The concept of thermodynamics is all definitely applicable for the conversion of energy. When you are going to understand the concept, the conversion of energy to the various forms, then we have to understand the thermodynamics. Without the concept of thermodynamics, we cannot understand, or we cannot explain, we cannot realize the applications of the energy. So for understanding and then explaining the different types of incidents around us, we are to understand the concept of thermodynamics. The thermodynamics compose the three types of laws, that is first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. We have to study regarding on the basis of this thermodynamics law. And there are so many applications or necessity of thermodynamics in but as per our syllabus, we have just focus on the classifications, definitions of thermodynamics, and the systems, and what is systems, and the application. So basically we are going to discuss as per our syllabus, that is we will discuss regarding these types of questions, and that is what is thermodynamic system, as we have already discussed, and then we will go for classification of internal energy. Basically, this is application. This is the main classification of energy. Energy can be defined, basically defined as internal energy and external energy. So energy can be defined as internal energy. You can say TER, internal energy, NAL, internal energy, ERGY, and then external energy, XTERNAL, external energy. So what is internal energy? Now we are going to discuss regarding the internal energy. Internal energy, the energy related to the intermolecular space energy, or the energy which comes from the interpersonal attraction between the molecules of a substance. So if you think that this is the solid substance, This is the solid substance. The structure of the solid substance can be defined as this way, and this. So this is the structure of a solid, which are in the solid states, and the molecules of the solid are in an array. So they are attracting to each other, and they are holding each other, and they are arranging a line of sequence, and then and all together have formed the solid substance. So in case of solid substance, we can easily think that the molecules of the substance are in an order, in a sequential order, and a sequence order, in a gradual order. When the order of the molecules of the substance will be break down, then energy will be released or energy will be absorbed, and the sequence of the structure of the solid substance will be destroyed. When the structure or the molecular structure will be destroyed, the substance will not stay in the solid form. So in that case, we can really understand that this is the solid substance, as the molecules of the solid substance are in a sequence, are in an order, arranged in an order. So this is solid substance. In case of solid substance, all the molecules are holding the intermolecular space. What is intermolecular space? The space between the molecules. The space between the molecule. This is called interspatial space. This is space, this space, this space, and this space. These are the intermolecular space, and all the molecules are attracting each other. Which are no intermolecular force. What is intermolecular force? The molecules which are the energy or the force which binds the two molecules together. Then the force is defined as the intermolecular force. I mean, the force which are lying between the two molecules, or the force which is binding the two molecules together. There, we can go for an example. This is a molecule, and this is the molecule. This molecule are arranging in this order, as the molecules are attracting each other through a force, and this force is known as intermolecular force. So we have really understand that the intermolecular force and the intermolecular space. Now the concept is internal energy. That the intermolecular force or intermolecular energy is known as the internal energy. So a solid substance constitute into intermolecular space, and the molecule attract each other. This is called intermolecular force, and the intermolecular force of a substance is also defined as the internal energy. Then what is external energy, or we can say we can go for just 1 minute. Another questions, that is such a okay. Intermolecular is energy. By intermolecular force can be defined in also another terminology that is we are going to discuss regarding that issue also. Then external force is the force which are related to the external source. It can be absorbed energy also, and it can be also derived from the different source, different sources of the energy. Then I mean light energy. It may be light energy. It may be external source of energy, that is what's radiative energy, and so many. So the internal energy বা স্ট্যাটিক্স এনার্জি, ইন্টারনাল স্ট্যাটিক্স এনার্জি, অ্যান্ড অভ্যন্তরীণ বাংলায় যেটাকে আমরা বলি যে অভ্যন্তরীণ গতিশক্তি এবং অভ্যন্তরীণ গতিশক্তি এবং স্থিতিশক্তি. So we can define basically the two basic part of the energy, that is the internal energy and the static energy and the kinetic energy. So another form of energy what that can be defined as static energy, static energy static energy and the kinetic energy. In our syllabus, kinetic energy, energy. In our syllabus, I mean the NU second year syllabus of physical chemistry under the chapter thermodynamics, we will go for static energy and kinetic energy. And the main discussions of thermodynamics in this chapter will be related to static energy and kinetic energy. What is the static energy? Static energy is really relevant to internal energy. I mean, this energy related to solid, energy related to solid structure, energy related to intermolecular force, energy related to intermolecular space. This is called static energy. What is kinetic energy? We know that all the substances are composed with a molecule, and the molecule are composed with the electron, proton, and neutron, and so many subatomic particles. When you are considering the concept of the subatomic particles or the electron, protons, and neutrons, then we can really understand that there is a movement or there is a velocity in these particles, in these particles, or the subatomic particle, that is orbitals. So in that case, we can really understand the movement of electrons. The movement of electrons relates a few energies. As a result of this, the energy which is produced is known as the kinetic energy. So we can straightly define the kinetic energy, the energy which is related to the movement of the electrons. This is called kinetic energy. Then static energy, we have already discussed the static energy or internal energy. And then when you are going to discuss the kinetic energy, so kinetic energy, you can definitely say that the kinetic energy is that type of energy which is related to the movement or the transitions of electrons. If you consider regarding the internal energy, then internal energy will be the static energy and the kinetic energy. So in a bigger concept, if we consider the internal energy of a system, then what is system? We have already discussed that any part of the universe is a system. So if you consider the complete or internal energy can be defined as E or U equal to kinetic energy, static energy SE, static energy plus kinetic energy KE. So in terms of a system, if you think that the internal energy of a system, then we should say that the internal energy of a system equal to static energy and kinetic energy. This is the ultimate equation of internal energy. So as a whole, we can now define as the internal energy of a system is the summation of kinetic energy and static energy. And already we have discussed what is static energy and what is kinetic energy. Now we will go for system. As we have already discussed that the system, any part of the universe is a system. What are the type of system? There are various types of system. You can say the open system, you can say closed system, you can say isolated system. There are three types of system: open system, closed system, and open system, closed system, and isolated system. So we can say the system can be classified as what is system? System is a part of universe, any part of universe, and system are classified into three parts. Number one, that is called open system, OPEN, open system, SYSTEM, and then closed system, CLOSED, closed system, SYSTM, CS closed system, and number three, isolated system, isolated system, SYSTEM. So now we are going to discuss regarding the open system, closed system, and isolated system. As we are going to the basic concept, so it may be someone can feel that he knows everything, and someone may feel that he is learning something new. But this concept will help us to understand the different types of mathematical equation in the days to come. So we are going from the zero concept. to understand or to develop our basic concept of thermodynamics. We have already discussed regarding the what is thermodynamics, what is internal energy, what is system, and what is the summation of internal energy, how they come from, what is the environment. Now we are going to study on the classification of systems. The firstly, open system, OS. OS, that is open system. What is open system? The system which allow matter and energy, to come in and to go out. So we already know the definition of system, that is any part of the universe is a system. If this system allow the matter or the energy to come in and to go out. If any system allow the substance and energy to come in and to go out, the system is called open system. So this is open system. As the substance are coming, energy are going. So this is open system. What is I mean, in a few example of open system, that is a tree, human, living system, living substance. These are open system. And then as closed system. What is closed system? The system which allow only heat to come in and to go out. The system, this is system, and a part of the universe system. If this system allow only heat to come in and to go out. Heat, this is heat, 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 coming in and going out, heat. So any system which only allow heat to come in and to go from the system, to come in heat to the system, to go out heat to the from the system, this is called isolated closed system. This is closed system, CLOSED, closed system, SYSTEM. And this is what? Open system, OPEN, open, SYSTEM. This is open system. Now the question is, what is isolated system? Now the question is, what is isolated system? Okay, we are cleaning the board. Just wait. Now we will understand the concept of isolated system, and it will help us to understand the different types of system altogether. So what is isolated system? The system which cannot allow any matter or any energy, no matter, MATTER, matter or energy, to go out and to go in. Heat plus matter. So you can easily say, if any system doesn't allow any heat or matter to come in and to go out, the system is defined as isolated system. I hope you have clearly understand the types of system. What are the systems? What is systems? What is environment? What is open system? What is closed system? What is isolated system? What is internal energy? What is thermodynamics? What is the application of thermodynamics? Why we will study thermodynamics? All the questions we have already discussed. These are all the things are basic related concept. This concept is very primary stage or fundamental basis of thermodynamics. If you understand, if you really want to understand the concept of thermodynamics, or want to realize the concept of thermodynamics, then you have to have the clear concept or crystal clear concept regarding the thermodynamics basics. So this is our first class, and we have discussed already the fundamental basis of thermodynamics. Then there are different types of parameters in the thermodynamic system. What are the parameters of thermodynamic system? The parameters of thermodynamic systems are the pressure, the volume, temperature, compositions, internal energy, enthalpy, entropy, gives free energy. These are the parameters of thermodynamic system. So we have already known the parameters of thermodynamic system. Then we will understand the very basic and common and popular concept regarding the thermodynamics, that is state function. So many cases you understand, or you will hear the concept of that internal energy is a state function. Then what is the state function? A state function is a function which is different on the values of some parameter. This is called a state function. That you can define as the fx. This is a state function. If you define something like this, then you can say that this is the state function. If equal to function of p v, then this is also a state function. Okay, when we are going to define any parameters, any characteristics to this way, then we can say that this is the state function. Then we are telling that the internal energy is state function, that is internal energy dE, that is the change of energy equal to 0. So this question may be settled in the final exam like this. Explain that internal energy is a set function, or prove that, just wait, I'm clearing the board. The question may come into the exam, or already have been settled to many exams. That is, explain internal energy, internal internal energy, GY energy is a state function. FUNCTION, state function, or prove that integration dE equal to 0. This is the very fundamental questions of thermodynamics, and we are to understand this concept because this is the starting of thermodynamics actually. So we are going to discuss the concept that the internal energy is a state function. Firstly, we have already discussed regarding the concept of energy. So on the basis of that concept, we will discuss that internal energy is a state function. So this is volume, and then velocity, and then time, and then you can define as this is a way of converting energy. This is one, and this is this. So this is EA, this is EA, this is EB. This is path road 1, path 1, or this is road 2 or path 2. This is A, this is B. When the energy move from A to B through the path 1, and then energy from B to A through the path 2, actually there will be no difference. We have to prove that the total difference of energy change will be 0. But in case of consideration of the way, if energy moves from this way from A to B, then EA and EB, the total energy change will be EB EA minus EB. For path B or section 2, we can say that EA minus EB, the change of energy. When energy move from one point A to point B, point AB, the change of energy will be EA AB minus E1. That is, we can say that EB minus EA, this one, EB minus EA. And then for part 2, that is section 2, this one, this is part 2, and you can say for E2, for 2, EA minus EB. So the total change of EA minus EB should be equal to EB minus EA. If there is any difference, then it will violate the law of thermodynamics. So that cannot be possible. So for path 1 of internal energy equal to the internal energy of E1, that is E, internal energy of path 1 equal to internal energy of path 2. So we can say that, just I am cleaning the board. This one. So we can say that EB minus E1 for path 1 equal to EA minus EB. More precisely, we can say that delta E equal to EB minus EA. The change of energy for path 1, this one, and for path B, this one. So grossly, if we define that, the total path A and B with respect to the path point A and B, we can say that EB minus E1 equal to delta E. What is delta E? Delta E is the denotion, is the notification of the complete change of energy of the complete path. So from energy, when the energy is changing or moving from point A to B and from point B to A, the complete cycle is fill up. So for a complete cycle of the journey from point A to point B, this one, A, B, this one, and then this one. So complete journey of energy from point A to B, 1, and from B to A, 2. The 1 and 2, the path 1 and 2 fill up the whole journey of the energy. So for a complete journey, the total change of energy will be EB minus E1, this one and this one. So delta E is the change of energy, internal energy. So delta E equal to EB minus E1. If delta E equal to EB minus E1, that means that the complete change of energy of the system completely depends on the depends on the internal change of energy, that is EB minus E1. So for a complete cycle, for a complete cycle, the total energy change of the system equal to 0. So so the complete integration of E equal to will be 0. In that case, we can say that integration delta E equal to 0. That is, there is no change of energy for a complete cycle. So the energy doesn't depend on the path 1 and the path 2. In that case, we can say that the quantity or the measurement of E of a system doesn't depend on the path. Either it is using path A or path B, but absolutely depends on the state. I mean the environment. So internal energy doesn't depend on the path, but for a complete cycle, it depends on the state. So it can be said that on the basis of this equation, it can be said that the internal energy is a state function, as there is no change of internal energy of a complete cycle of a system, for a complete cycle of a system. This is why we can easily say that internal energy is a state function. If there is any changes of energy, then we cannot be able to say that the internal energy state function, and it absolutely contrary or contradictory to the thermodynamics law. As a result of this, we can say that internal energy state function and delta E equal to 0, and then delta E equal to EV minus EA. That's all for these questions. So at the end of this class, we can summarize that what we have learned. What is the outcome of this class? After completing this class, when you are going to finish this class, you just study what the topics you will go through from your main books. As you know, I suggest the physical chemistry books from the students who are starting in English medium. That we have already discussed the books listed, or what we have to you have to buy for, or you will follow the handout. All the handouts that are required will provide. So you can easily think that you will get the handout for English version and Bangla medium. Okay. So what is the outcomes of to this class? Number one, thermodynamics concept. Thermodynamics concept. Number two, system details. And then classification. And then four, concept of internal energy. Concept of internal energy. And then the concept of state function, and then concept of state function. And the explanation of the concept explain that delta E integration delta E equal to 0. These are the questions that we have understand that we have already discussed regarding today's class. I hope you have enjoyed the class, and in futures we'll go for animation mode for the another topics. As we are going to the basic concept, and then we will be required to have the another basic concept of from this chapter, like entropy, enthalpy, and the change of entropy and the characteristics of enthalpy, and then we'll go for the question to question discussion of this chapter. And all the list of the questions that have to understand and that have to study for the final examination has been given to the website. So you can go to your page and you can check out there. So thank you so much for staying with us.